size, different feet of radar technology surveillance system. They are with us under their guidance. Our student, because we have a lot of strong young manpower with us, almost in our campus, always 4,000 students is there. So with their help, we will try to start innovation council in a big way, and we are working in this direction. Now our objective is to make awareness to the Institute Innovation Council among the BIT campus stakeholders, to motivate young minds toward the planning of their own startup after the completion of their graduation course and institute level of innovation, to create the young minds about the legal and ethical steps. We express details process of their ideas and actual business related to action to development of our students. So we are going to be acquire knowledge from different sources of like seminars, symposium. In addition to that, we have signed on MOU with one of the USA company who is going to give our students every month 1 or 2 seminar on blockchain technology, the typical from USA, and they will take our student as an internship in the 3rd year, and the same project they will convert into their main project in the final year. If they are found suitable, they are dedicated, suitable for them, they will make the recruitment. That is the process I'm starting. And this seminar, particularly this blockchain technology, we have 2 experts from the renowned institution, IIT, they are going to give lectures. These are the milestones. They are putting a step of this, getting this goal. So the 3-day seminar will bring a lot of opportunity our students to learn from different eminent professors or scientists about what is the blockchain technology. In addition to that, some of the speakers will come from our MOU partners also. So I think this will give a sufficient knowledge, and it will share the sufficient knowledge to our students, our faculty, to start not only employment to our students, they can start their own thinking. Now, to the blockchain technology, the big way being used in the USA and all the European countries, I think with the supports, our institute will also going to be the joint pool of them and start our Institution Innovation Council. I express my gratitude to all the speakers, particularly Dipan Sahu, who has to guide them both the best to us in long way, or both the professor. I also invite them in future also to guide our students. And I wish all the participants, I request them to take the maximum advantage of this seminar. Thank you, sir.
Thank you so much, sir, for your wonderful words. Now, I would like to introduce our Honorable Chief Guest, Mr. Dipan Sahu, today, who we are very fortunate to have, sir, with us. Sri Dipan Sahu, sir, started his career as a social entrepreneur and then turned to a policy entrepreneur, having more than 10 years of experience in policy design, implementation in the domain of innovation and startup ecosystem development in higher educational institutions. He is presently working as Assistant Innovation Director at Innovation Cell of Ministry of Education, housed at All India Council for Technical Education, AICTE, New Delhi, with a mission to make Indian higher educational institutions innovative and entrepreneurial through conducive policy interventions. He manages a portfolio of policy programs related to innovation, pre-incubation, and entrepreneurship promotion at the Ministry of Education's Innovation Cell and AICTE. He is the core team member for the implementation of the National Innovation and Startup Policy (NISP) for higher education institutions. He is also playing a lead role in the designing and implementation of other major national policy initiatives such as Atal Ranking of Institutions on Innovation Achievement Area, Institution Innovation Council, and introduction of a new academic program, MBA in Innovation, Entrepreneurship and Venture Development, IEV, in HEI to offer and produce job creators from academic institutions while making Indian higher education innovative and entrepreneurial. With this, now I request Mr. Dipan Sahu sir to address the audience and the participants.
Yeah. Thank you, Dr. Papaya Dattaji, for coordinating this event, this symposium, very methodologically, systematically, and also in a planned manner. My sincere thanks to Dr. J.P. Singh ji, the principal of Bharat Institute of Technology, Engineering and Technology, Telangana. And also, I'm very much happy that your institute has started the establishment of Institutions Innovation Council under your leadership. And you have started conducting so many activities, though you established the IIC recently, but the kind of passion and the involvement of the team in organizing and activating the innovation and entrepreneurship ecosystem in the campuses, which is very, very important nowadays. Because the students, those are coming to the institute and they're spending more than 3 to 4 years of their very productive years of their life in the formative stage of their career. And in addition to the knowledge they will acquire from the core subjects, they have to also acquire the skill set and the mindsets towards innovation and entrepreneurship. Then only it will help them to stay competitive and also survive in this in our competitive market, where every day they have to be innovative, and also they have to behave and act like an entrepreneur to to identify the opportunities and also to provide the best solution and utilization of the talent of our youths. So that's why actually our Indian ecosystem, where the higher educational institutions and the youths are studying there in these higher education institutions. The faculties, those are part of these higher education institutions, they are the major stakeholders where this skill set, the mindset, the attitude, and the engagement opportunities for these faculties and students to get engaged in innovation and entrepreneurship activities are required. That's why to address this need and the challenges of not having any kind of a system-based approach, that's why this Institutions Innovation Council model we came up. And in last 2.5 years of implementation, actually now more than 3,000 higher education institutions have established these IICs. And because of this IIC establishment, now it is actually helping, now it is actually easy for the higher education institutions to organize, to bring the talents, bring the faculties, experts, and the students together into one platform. And now through this knowledge sharing and also through collaborative mode, they are organizing the activities, innovation and entrepreneurship activities around the year. And our students and faculty are getting maximum exposure and opportunities to participate in these activities and understanding the jargons, the terminologies, and also they, which actually helps them to think that, and they're now realizing that innovation and entrepreneurship could be or can be one of the alternative career option for them. And many of these students, they are actually choosing this startup as a career option in last 2 to 3 years, and that trend has been in upward, and many of the number is increasing every year. And IIC is one of the instrumental for creating this and building this kind of culture in our institutions. And this is the what actually we are aiming for. In addition to this, we have the other programs like auto ranking of institution on innovation achievement. Actually, it's a innovation ranking framework. And this innovation ranking framework is unique in terms of it has it just classified the whole ecosystem into different blocks, and it also has attempted to define the ecosystem in a very objective method, where we can generate the data, and the data will be help in quantifying the ecosystem, that actually up to what extent we are good at in which component, and actually where the institute is lacking and where they should more focus and they can mobilize the resources. So this auto ranking of institution on innovation achievement, this ARIA framework itself is one of the innovation in terms of the ranking framework, especially in the developing countries like India, where the ecosystem is in very nascent stage, and mostly we are at the input and output level, rather than input and the process level, rather than we have matured at the output and outcome level. If you will see the ecosystem of our country, we are mostly into the at the input level or at the process level, like we are conducting certain activities or we are producing some trained manpower, but still we have to go for producing more innovations, more startups, and more entrepreneurs. This is what we have to achieve. So slowly we have to move our focus. Once the input level and the process level will streamline, then we have to start focusing on the output level and the outcome level, and where our higher education institutions and the students and the faculties, those are part of this. Actually, they have this potential and the opportunity to lead this ecosystem of our country. Now comes to the today's session. Actually, I'm really happy that lead institutions like Bharat Institute in your zone, you all are taking the leadership role in conducting the seminars and the symposiums in the area of emerging technologies like blockchain, and also trying to connect this blockchain with the application part, especially the innovation and entrepreneurship. See, if you will talk about the innovation and entrepreneurship, actually both are moving and revolving around the opportunity creation, right? So innovation and entrepreneurship is for the opportunity creation and how to utilize that opportunity for the betterment of the society or the livelihood or the wealth generation of the country. If this is the core of the business innovation and entrepreneurship, then this business opportunity actually lead by the two factors. One is called the technology advancement, that how we are advancing our technologies and we are adopting the new technologies. Then the second one is what is the market need, or what our customer, what our people actually looking for, what the kind of problems we are going to solve for our society. So these two factors, when combined, it creates the huge opportunity for the business, and where the entrepreneurs and the innovators from our higher education institutions, they try to address that problem or address that challenges, and they convert the challenges into the opportunities. This is the methodology or the approaches every emerging and developed economies are now adopting, and this is exactly what with no difference India is also doing the same thing, because we have targeted to reach to a $5 trillion economy by 2025, and we have to put our country into the top 10 economies in the world. And if we have to achieve that, then again we have to fill the skill gap and technology advancement gap that is existing in our society. And for that, this innovation and entrepreneurship and the market requirement, and accordingly alignment of our technology and aligning the mindset and the skill set of our people is also need to be streamlined. And through this symposium, actually, I hope the research on blockchain and application of the blockchain to enhance and streamlining this innovation and entrepreneurship, so that our student, our people, our faculties will actually able to make the opportunity better for a business creation will happen. Now comes to this some facts and some information about the blockchain. Actually, if we will talk about the blockchain, actually this comes under the fifth industrial revolution 5.0. In the last 4 to 5 years, actually, India has actually started embracing the industry 4.0, where artificial intelligence, machine learning, and the big data analysis, actually now it is become more frequent and more common among the academics and in our higher education institutions. But see that with just 3 period of time, again, we started getting knocked by this industry 5.0 technologies like blockchain. So that means the industrial revolution period actually getting certain in when we progress, when we advance, and in coming days also more and more such technologies will come so quicker. So we have to stay ready to embrace this kind of changes, and also have to adopt as soon as possible. For that, we have to enhance our capacity, enhance our competency, and also we have to make it use in the practice at the earliest. Neither we will miss, there is every chance that we will miss the bus, and after that again what the actually goal and what the aspiration actually we have set for next 10 to 15 years, again it will get further delayed. And this is what actually this competitive spirit among the youths and among the people, among the stakeholders, and through collaborative and through co-creation mode, this is actually what model is we are expecting from all of our stakeholders, from higher higher educational institutions and the industry experts to come together. Blockchain technology actually has a wide application. It is actually still we have not picturized the whole thing that actually where blockchain is going to fit, but in a common sense, blockchain has a wide application, and like internet, like World Wide Web, it has the similar kind of opportunities. So like internet has created disruption in the communication sphere once it was introduced, similarly blockchain is going to disrupt the especially the data recording and the digital data recording, or the all kind of things, especially in the area of finance and commercial sector. You name it, the sector like retail, logistic, next finance, government, or the manufacturing, all these sectors where the data is getting generated every day, and also the data is very, very essential and the sensitive data which need lots of security, which needs lots of integration. All these sectors have a great and tremendous potential to adopt the blockchain technologies. And this blockchain technology also gives a very kind of a very robust and the platform and the system approach to maintain, to generate and to integrate and maintain the data in very secured way, and using the low cost, easy to use, and high secure mode of keeping this data in digital way. This is the way actually blockchain is the potential, but there is lots of research is required that how each and every stages of the application of blockchain, and also cross application of the blockchain for the different sectors, and at the institutional level, at the individual level, how this blockchain is going to govern the life and the business process, and also generating lots of trust among the stakeholders, because business also deals and also have one of the foundation is called the trust and the data security, where this blockchain is going to fit best. And I believe next 2 to 3 days, where this symposium is going to address the each and every aspects and the domain of the blockchain and the sector where this blockchain has every chance for the adoption in next 2 to 3 years. And our experts is going to talk about in detail, and also they will highlight the challenges and the opportunities, and also there will be a space for our stakeholders and the participants to come up with their own views and opinions, where through this kind of a knowledge sharing platform we will discover the newer aspects of the blockchain to apply, and also come up with innovation and entrepreneurship at the institutional level. With this, I will thank again Bharat Institute of Technology and all the stakeholders, the experts and the participants for coming together and part of this symposium. And I believe the next 2 to 3 years is going to be actually excellent time for each and every one to broaden their understanding and also a skill set on blockchain technology. With this, I will thanks to the Bharat Institute of Technology for organizing this symposium, and all the best to the my participants.
Thank you so much, sir. Yep. Thank you so much. It's really pleasure, sir, that you have taken out your precious time, because you are very busy as you are undergoing the Innovation Ambassador Training Program. It's a 1-month training program, and daily there are sessions. And we'd like to inform you, sir, that we are 7 faculties who are nominated as Innovation Ambassador, and we are completing this session as well as assignments. A very nice one, sir, and really we are learning a lot from it. So thank you so much, sir, for coming to the inaugural function today. Thank you. Now, I would like to request Dr. Amit Agarwal, sir, to introduce our today's speaker, Dr. Debasis.
Good afternoon, all. This is Professor Dr. Amit Agarwal, Associate Professor, Department of Electronics and Communication Engineering, Bharat Institute of Engineering and Technology. It's my privilege to introduce today's speaker, but before introducing the first speaker of the session, I must thank Mr. Dipan Sahu for his valuable guidance regarding the innovation activities. I must thank him also because I'm the area in charge for this particular institute. Sir, if you're hearing me, I'm very much thankful because way back, just 2-3 months back, when we were about to submit the ARIA documentation, I was being little bit confused regarding the things what should be kept in the ARIA portal, especially regarding the innovations. But the webinar you conducted was so informative and so expressive that I was being able to complete the task within the time frame. So thank you, sir, for your valuable guidance you have provided me, especially in that particular webinar. Thank you so much, sir. Now I would like to introduce the first speaker of the session for today's program, Dr. Debasis Das, the eminent speakers for the today's session. Dr. Das has received his PhD in Computer Science and Engineering from Indian Institute of Technology, Patna, Bihar. He received his MTech in Computer Science and Engineering from School of Computing, KIT University, Bhubaneswar, Orissa. He joined IIT Jodhpur in 2019, and before joining IIT Jodhpur, he was working as assistant professor in NIT University, India, and BITS Pilani KK Birla Goa campus. His research interest includes vehicular ad hoc networks, cryptography, security, blockchain, Internet of Things, smart cities, intelligent transportation system, machine learning, and artificial intelligence. Dr. Das has published many papers in top international journals, especially IEEE transactions. Dr. Das has 7 sponsored projects, out of which 3 projects are from DST, 1 sponsored project from GITA, and 1 sponsored project from MHRD, as well as 2 sponsored projects from BITS Pilani, to his credit. Earlier, he has been involved in the Ministry of Electronics and Information Technology, Government of India, research-funded project where he has actively participated in developing the centralized and distributed algorithm for vehicular sensor and mesh network-based future ITS. His current research interest includes distributed and centralized algorithms for smart transportation. To his credit, he has been awarded the Early Career Research Award from Science and Engineering Research Board, SERB, Department of Science and Technology, Government of India, for sponsored research project titled Secure Vehicular Communication and Routing in Future Intelligent Transportation System, ITS. We welcome you, sir, for the today's session. I hand over the session to you. You may proceed, sir. Thank you.
Okay, thank you, Dr. Amit Agarwal, sir, and thank you for this invitation. And this blockchain technology is now a new technology, and this is the hot topic. Okay, and so, but this technology is under somehow some advantages as well as have some challenges. So, how we'll resolve those challenges? Okay, this is the basically difficult job, and some background is required, some basic understanding which is related to some foundation knowledge, and then as well as what are the opportunities. Okay, opportunities in the terms of in the terms of research, in the terms of jobs, and in the terms of like industry oriented collaboration or something. Okay, so product development. So this technology is under like different application area in the area of blockchain. So we can apply the blockchain for the smart transportation. We can apply the blockchain for this smart grid. But we have to think that which type of problem we have to tackle. Okay, it's not like that anything you can directly use the blockchain for this thing like for any application. Then there is a possibility it is cost means highly cost oriented, or it is in the costly technology. So that's why somehow we have to think, and based on our requirement we can apply. So large number of companies, they are working on the basically in this area blockchain domain. Basically in the banking sector, they want to in future implement the blockchain technology for their requirement. Okay, and as well as the multiple means private public sector, they also working on the same technology. Government also want to implement the some of the or using the some of the government offices and government sector implementing the blockchain for the secure communication, for the secure or efficient storage purpose. Okay, security, integrity, as well as the storage. Okay, and sometimes also consider the privacy issue also. So some of the medical organization also want to apply this thing. So this is the new technology, and also student point of view, it is very important because the all these software companies, they already some of the companies, they already designed the blockchain technology cell, like the TCS, Infosys, and as well as the Microsoft. So they already designed the some only specific cell for the blockchain oriented technology. Okay, so in general they have the something like simple research and R&D cell, as well as they have the more specialized cell in the area of the blockchain. And also top university in our country as well as the foreign country, they already have the different school for the blockchain. Okay, or different department, separate department for the blockchain. So in future there is a huge opportunity in the terms of job, in the terms of higher study, in the terms of collaboration, in the terms of research. So okay, so in the today's talk I will discuss the what is the basic blockchain concept and how we apply in the case of transportation application, and as well as the what are the future opportunity for the student perspective as well as the faculty perspectives. Okay, so faculty have the some opportunity, how they collaborate, what are the companies they can collaborate with the blockchain technology, or how the faculties are directly write the project proposal in the area of blockchain. And also the paper means faculty can publish the top tier IEEE transaction or AICTE type of conferences in the area of blockchain. Okay, so that's it.
Sir, you can share the screen. Sir, you can share the screen.
Yes, so I share my screen means just 1 second. Yes. It is visible?
Yes, sir, now it's coming.
Yes. Okay, so my okay, so today I am going to discuss the blockchain for smart transportation and why we select the smart transportation and why in the transportation system the blockchain based solution is important. Okay, and what are the benefit using the blockchain technology and who are benefited. Okay, what companies are benefited, government are benefited, how they benefited. So this thing, okay, these are the in details discussion in this topic. Okay, so in the smart city there is an n number of the pillars like smart transportation, smart healthcare, smart grid, okay, smart home. So here we consider the smart transportation, and smart transportation means basically the intelligent transportation system, means intelligently we can measure the traffic condition, we can measure we can predict the total number of accident, we can optimize the traffic flow, okay, and also the like smart mobility, smart parking. So all these things is known as the smart transportation. So through the smart transportation we solve some of the challenges or solve some issues using the intelligent transportation system or smart transportation system. Okay, and here in this talk, so in the smart transportation, how this blockchain is play the important role for the security perspective, for the storage, and for the privacy. These are the three concerns. Okay, so that's why we apply the blockchain in the case of smart transportation. But it's not like that directly we apply this thing. So somehow we have to create some model. Okay, and based on the model, top of this model, we can use the blockchain technology. Okay, and what is the blockchain and how we apply, what are the modification? If you apply the blockchain technology, then your computation cost is too high. Okay, as well as your infrastructural cost also too high. So somehow you have to modify the blockchain technology and then you have to fit into the smart transportation. Okay, so somehow I'll give you the overview idea as well as how you implement all these things. Okay, and then after that I'll discuss the what are the challenges, means what are the opportunities. Okay, so now why we select this smart transportation? Because this is the serious problem. But how it is serious? Okay, so we first formulate the problem. So we explain here that then the serious mismatch between the growing traffic volume and availability of the resources to support the traffic. So means there is another growing the traffic volume day by day increasing, okay, population as well as the number of car user, all these things, but number of roads and road infrastructure is under basically limited. Okay, so this is a serious mismatch, and this important reason of this mismatch are rapid development of our economy, okay, as well as the society, okay, and as well as the multiple vehicles per family. Okay, so our objective is that we believe that this mismatch will continue to grow, okay, and until we design some efficient solution or intelligent solution. And so here we discuss some solution which is efficient as well as the secure. Okay, and this solution is based on the blockchain. Okay, so we can, without blockchain we can provide also some solution, but with blockchain, so in this talk we explain we can use the blockchain concept and solve these challenges. So this, what are the challenges? Challenges is basically this serious mismatch is there. So intelligent algorithm is required to this intelligent algorithm is responsible to solve these issues. Okay, so now, so why we assume the blockchain is mandatory as well as the smart transportation? So what is smart transportation? This is the basically important question. So what is the smart transportation means? We assume the all vehicles, transportation means vehicles, all vehicles can communicate, okay, to each other. Okay, so we assume that each vehicle have the connected device or like the IoT type of devices, inbuilt devices on the vehicles, and through this device they can communicate with the other vehicle or they can communicate with the roadside unit, and this communication based on the different type of communication protocols. Okay, so this is the basically in general concept. So here, so that's why, but this thing is possible. Okay, so that's why from the literature we check. Okay, so day by day increasing the connected car sales. Okay, so a prediction of the car sale with the some form of connectivity till 2025. This is on the result. So this feasibility is there. In future, the large number of the car with the connectivity is there, and all automobile industries also add this concept on the vehicle with the connectivity. Okay, so then we can in future after 2024 or something, we can implement this thing like this type of solution. Or in the case of some of the country, they already have this car with the connectivity concept. So they already implemented not blockchain based solution, they implemented some smart transportation related solution. Okay, so I'll explain all these things. So now this thing is also feasible. So we can think that here some solution which is related to the blockchain. Okay, and but so this is so what is our objective? Our objective is somehow efficiently communicate the communication between the vehicles as well as the secure communication. Means if the one vehicle want to transmit some information, okay, to the other vehicle, so intermediate user is not able to access the information. So because sometimes the vehicle want to share some personal information or something like that, so no one can access the information. Okay, so that's why the security aspect is there, security concept. So traditional security mechanism is available, but we want to apply the blockchain, and which is resolve the security as well as the privacy as well as the efficiency. Okay, so this is our objectives. Okay, so in general but what type of, here I mentioned that they want to share the information. So what type of information they share, and based on the information how we are benefited. Okay, so like here through this communication there is a possibility they can share the active road safety related information, or they can share your traffic efficiency. So they can, through this information we can predict the traffic, or we can manage the traffic, we can control the traffic, okay, and then the entertainment related applications. Okay, so these are the basically main things. This is in details. So here we are using the, for the transportation in general, we are using the one networking concept, vehicular ad hoc network, which is solve this transportation issue and basically reduce the congestion, okay, as well as improve the road safety, okay, as well as the comfort, the both means convenience as well as the comfort to the both driver and passengers. Okay, so these are the basically in general benefits. Now this thing is under this vehicular ad hoc network and vehicle to this is under some limitation is there. So that's why the companies are, this is not a technical and business related limitation is there. So because they only have the two types of communication, okay, and other devices are not able to communicate with them, and large number of companies, they are not interested to this infrastructure because this infrastructure is not new type of infrastructure and they are using the old concept and old protocol. Okay, so that's why we think that somehow if we change the infrastructure and when we change the infrastructure, then we think the how we blockchain, we apply the blockchain on the modified infrastructure, and then we benefited the both thing in the terms of performance, in the terms of security, both things. So performance means like the energy consumption is very less. Okay, efficiency of the network, they can easily transmit the information. Okay, and as well as the we have the other means delay also less, as well as the other parameter we can consider. Okay, so this is the in general traditional concept, the old concept. They are using the one specific protocol DSRC, and through this is and this model is not efficient. Okay, so that's why our objective is we can design the one new universal architecture for this smart transportation. Okay, which is basically responsible for the efficient communication, secure communication, large scale data sensing and computation, data collection, so multiple things, as well as the provide the solve these challenges, safety, traffic efficiency and infotainment. Okay, so that's why we finally come up with the like vehicle can communicate with the any devices. Previous time vehicle only communicate one other vehicles and the roadside unit, but here we assume in the smart city vehicle can communicate with the any other entity, means either roadside unit or house entity or the base station or the your grid, anything. Okay, so that's why the here these things and the here if you check the communication is on the heterogeneous. So heterogeneous means it is very complex. Okay, so multiple devices we have, vehicle can communicate with the multiple devices, and these devices have the different type of capability, they have the different type of communication type, they have the different type of communication protocol. So then we have to, so vehicle have the all type of thinking, so they can communicate with the all other entity and share the different type of information. And information means just I means safety related information, means warning information, okay, or the assistance information. And then the also vehicle can share the in the specific region wise from the vehicle, we can through the GPS we can collect the information, we can estimate the traffic, okay, or we can estimate from the this vehicle related information or roadside information, we can estimate the what is the prediction of the road accident or multiple things. Okay, and now why we consider this thing, this vehicle to vehicle communication or vehicle to transportation in the vehicle to other device communication is mandatory, because from the literature we check the this on-road vehicle day by day it is increasing, okay, worldwide, and due to this there is a possibility for due to this day by day increasing the motorization rate and the congestion problem is there. Okay, and what is the problem? If somehow we can apply this vehicle to vehicle or this type of communication scheme for the smart transportation, then automatically reduce the 60% of the accident if we alert the driver before the collision. Okay, before the collision, at least the time is warning message like 1.5 seconds before, as well as the somehow in the traffic jam is there. So if we use the some, we can apply the some concept which is basically remove the traffic congestion, okay, and solve the traffic congestion problem, then if there is a benefit for the 5 minutes, okay, so then and expected to generate around 25 billion euro revenue per year. Okay, so this is the expected generation. So if we somehow minimize the means optimize the traffic control timing, so then this is the benefit. As well as the automobile industry, just I mentioned, the day by day increasing the on-road vehicle user. Okay, so that's why the automobile industries also play the important role, and they expected to increase the profit margin of the 54 billion euro in the year of 2012 to the 2020. Okay, so 54 to the they automatically increased to the 79 billion. So these are the benefited, okay, from the literature and from the existing. If we solve this problem using the some techniques, okay, so this techniques is not only the efficient technique, as well as the we have to have the high level of the security, because some of the important information, okay, only the sender and interaction between the sender and receiver, not like the any intermediate person. So because we want to include the security concept, because our channel is open channel in the smart city, anyone can communicate with any other person. So that's why the security is more concerned, as well as the all traffic related information, all your this information, vehicle related information, driver related information, all these things we have to store somewhere. So that's why the blockchain is on the first one is blockchain we apply for the security reason. Then second concept, we apply the blockchain for the storage perspective. Okay, and third one, we also think the privacy issue. Okay, so privacy also is solved the privacy thing also using the blockchain concept. So now everything you know that this is based on the IoT type of thing, Internet of the thing. So previously the VANET research is ongoing. Nowadays everything is on the IoV. So IoV is on the Internet of the vehicle, which is the concept of vehicular ad hoc network and Internet of the things. So this is the combined concept. So this is the heterogeneous concept, and it is have the huge market opportunity. How the market opportunity, this thing I explained. Okay, and then this is the basically our application area, and in the application area, what type of solution we have to use? We have to use the solution blockchain for the security and for the storage and for the privacy purpose. And this IoV thing is for your communication perspective. Okay, so now what type of benefit if we are using the IoV? Then this is the intelligent transportation system to enhance the traffic, to avoid the accident, to ensure the road safety, to improve the driving experience, as well as the. So here we consider this IoV thing. Basically, we consider not the n number of devices or something. Here we consider in the smart city in general 5 types of devices: vehicles, roadside unit, infrastructure, portable device, and as well as the sensors. So any device either belongs to the vehicle or belongs to the roadside unit or infrastructure or portable device. So this is our assumption in this infrastructure. So we created the one infrastructure and we categorize if it is a sensor, then we belong to the sensor. If it is mobile device, then we include into the portable device category. Okay, so vehicle can communicate all these type of communication. Okay, so this communication is related to the sharing some information, related to the some prediction. So all these things. Okay, so now and here types of communication, we are using the different types of protocol. Okay, when the short range communication, we are using the short range related protocol. When our communication is long range, then we are using the 4G type of concept. Okay, so this is the basically concept. And now what is the benefit? If we are using this IoV type of concept, benefit is that it is highly commercialized. How? I'll explain. So, and as well as the this is then the different type of smart commercial as well as the infotainment application. It is a heterogeneous network. Just I mentioned that any device can communicate, not only specific type of devices, and also any type of communication protocols. Okay, so this is fully heterogeneous. Then here it is where the reliable internet services there. Okay, and as well as it is also sometimes we include the cloud for the high computation power. Okay, so initially they can share the information with the huge amount of information stored, and we can use the high performance computing using the cloud computing. So this facility also we can include here. Okay, so then Now, if we think like this type of infrastructure we want to set up for our city, okay, this is feasible for our country or it is not feasible. Okay, or it is just like a logical thinking, or you want to design or something like that. No, so that's why the feasibility thing is there. So feasibility wise, we verified the other country like the Europe and as well as the your US and Japan. They already implemented similar type of concept for the smart transportation. Okay, and it is working properly. They already reduces the accident rate. They already improve the traffic control. Okay, as well as their smart city communication, and also the property losses also they reduces. Okay, so from this literature, and they are using the communication thing, only the smart communication, vehicle to vehicle, vehicle to infrastructure. But here we included the more concept because we want to enhance the idea. Okay, so not like that they are using the vehicle to vehicle, then so we with the some so here we are using the concept, we propose the concept 5 types of communication, and as well as the all this project is related to the communication, data transmission, but some of them they are using the some security concept. But security concept now it is also the challenging thing. Okay, so here we are using the security concept, not only security, we are using the concept of blockchain, and blockchain will provide the security and as well as the storage concept. Okay, so then who are benefited? Okay, if we solve this type of problem, okay, and then if we working on this type of thing, so then the transportation means, you know, the automobile industries play the important role, like your Ford, Audi, BMW, Maruti, all this, and as well as the industry include, because here communication component is required inside the car. Just I mentioned this thing, the communication device is there. So that's why this communication device is responsible for the communication. So that's why the IT equipment companies also play the important role. Okay, as well as your software industry and as well as the internet service provider. Okay, and research opportunity, if you want to security concept, so you can identify the new security threat. You also concentrate on how you optimize the communication overhead. So these are the basically some research challenges opportunity. Okay, so now in general, what is the problem? If we want to include the high level of the security, then there is a trade-off between the security and performance. Then we degrade the performance of the system. This is so somehow our objective is we have to solve this issue. We maintain the high level of security as well as also keep somehow the high level of the performance of the system. And what are the existing approaches are available, they will not provide such type of thing. Okay, so this is our object. And security means somehow our channel, when the one vehicle want to communicate the other vehicle, so then we in general encrypt the information, and after the encryption we send this information through the open channel, and receiver receive the information, we decrypt the information and check what is the correct information. So in our case the information means anything, either vehicle related information, traffic related information. Okay, so these things are there. Now blockchain, so blockchain technology is in general, because in the previous talk and as well as some of you already completed some course related to the blockchain, as well as you have some idea. So just try explain. It is the most known technology. Okay, and this is the cryptocurrency. It is the Bitcoin. Okay, and blockchain is the decentralized concept. Okay, core idea is the decentralization, because nowadays everything our till date all this solution is the centralized solution. Okay, most of the solution is the centralized solution. So this is basically your decentralized, and okay, and blockchain does not store any information in the centralized data set. Okay, and here in the blockchain the all member can participate. Okay, all computer, all member, and they can share the information on the blockchain network. And in the blockchain, when the new user want to add, so we can create the new block. Okay, so this is and we update the whole this chain. Okay, I'll explain just with the figure. And in the blockchain, basically it is fully distributed and robust network. Okay, and blockchain is accessible to the everyone. Okay, not controlled by any network entity or something. And in the blockchain, there is the consensus algorithm is there, which is basically provide you the all these things is and depend on the consensus algorithm, which is then you provide the set of rules. Okay, so in your blockchain, how it will work? Okay, is all these things, all agreement, all participant, everything is in the inside the blockchain. There is the consensus algorithm is there, so we can set our new rule or new concept or all this agreement in the blockchain, modify in the case of consensus mechanism. Okay, so here if you check that this is then the overall concept in the case of blockchain. So we are using the same concept for our smart transportation. First, then blockchain entity is requested for a transaction. Okay, and this transaction is in our case basically the one car want to add into the blockchain network. Okay, so like that, and this car is in future participate for the communication. Okay, and then if we provide this type of solution, then what is the benefit? So then one car can share the any information with any entity of the smart city and smart transportation, and means any other user, okay, unauthorized user not able to access the information. Okay, this is the overall concept. So this is under this transaction of the so first is the transaction is broadcasted to the all nodes in the peer-to-peer network. In general, they create the peer-to-peer network. Then after that, this thing, the network node is validate the transaction using the public key cryptography. So here the security purpose we are using the public key cryptography. Then verify the transaction. Okay, after the verify the transaction based on this participant. Okay, then this transaction is created, and we can create the new block, and this block is verify the transaction and link to the other transaction and create the new block, and new block is added with the old block. So this is now your chain is this is your whole chain. Previously up to this chain, then complete the whole transaction. So here in this case, when the vehicle want to join into the network, so they create this type of chain with a large number of vehicles. Okay, if we create such type of thing, so then there is how it will give in our case the high level of the security and high level of performance. This is our basically objective. So here in general the blockchain is basically public and private type of blockchain is there. Okay, and well-known public blockchain is the Bitcoin, okay, and Ethereum, and as well as we have the two things. One is the consensus algorithm, second one is the smart contract, okay, inside the blockchain. Okay, so now this is the in general the data block. In general, inside each block we have the previous hash, okay, pseudo random number or random number, timestamp, and then the market tree concept. Okay, so like this way hash based tree concept is there. Okay, so this is then the overall concept, and one block if you want to join the initially you have the k number of block. If you want to create the another block, so this block is created and this block is joined with the previous block. Okay, this is the overall concept, and it is some properties is there distributed ledger and no centralized parties. Okay, and then we have the two component. What is in the consensus algorithm, and second one is we have the smart contract. So if we want to design some new application, okay, so we have to, so this smart contract is smart contract is a programmable application that run on the blockchain. So we have to modify on the smart contract thing, and we have to modify in the case of consensus algorithm. Okay, so then we can how we modify? We modify in the terms of we have to check what is our objective. Our objective is enhance the security. Then we have to think what type of modification is required. If we want to concentrate on the performance, means like there is the consensus delay is there. So how we reduce the consensus delay? Then we have to think like this way. We have to reduce this parameter, and then we can modify all these things. Okay, so these are the basically, and sometimes the 5G concept also easily we can use the blockchain thing. Okay, so these are the property of the blockchain. Now here, if you check, this is the smart city based communication, 5G based communication. This is a smart transportation. So here, if we create like this type of network or model, then we can use the blockchain based smart transportation. Okay, and if our network is something different, then the blockchain network is and the blockchain thing is and the not suitable solution. So somehow we can create the model like this way. So if the vehicle can communicate with the other vehicles and other entity, and they can create the individual vehicle can create the each individual block, and then based on this they can communicate. And this communication is basically a secure communication, and not only secure as well as the using the blockchain concept, which solves the security issue, privacy issue, as well as the storage issue. Okay, so this is the basically concept. And now here just I'll give the one real life application thing, like here smart transportation you mentioned. So any devices, so here we create the like distribute when the large number of devices or something like the, in this case if we consider the simple IoT type of devices, or in our case the devices means only vehicles and other entities. So here the other entities and vehicles, all these things are there in the smart city scenario. Now we can categorize them, and here in general in the case of security means we have to have the authentication and we have to have the integrity and confidentiality. So we have to satisfy the all these three requirements when we design the some security concept. So here in this real life application we are using the blockchain concept. So any device when we want to when any device want to join into this blockchain network, so before the joining they have to register into the blockchain network. Okay, so this is the assumption, and when they register into the blockchain network they receive the some identity, okay, as well as the batch number. So we categorize because when the large number of devices or large number of things, so we can divide it into the different group. Okay, and we have to identify the specific device wise their identification number. Okay, then we are using the based on our application wise we can use the public blockchain or private blockchain. So in general if we are using the public blockchain or Bitcoin type of concept, then when the each so these things are there, each device have the individual ID as well as the batch number. Then device want to join into the network, so they can create the individual block, and then when they create the individual block, then this block is added into your previous chain. So this device added into your network IoT network, and then this device is able to communicate to the other devices. So if the all devices are registered and all devices is created the block and they created the one long chain, then they can participate for the communication. Okay, now our objective is basically the how we prove that this our communication is efficient communication and our security is on the high level security. Okay, so just I mentioned that we can use the blockchain and create all this concept, and we modified little bit into our consensus algorithm, which is basically gives you the performance, and we also modified in the smart contract and also maintain the high level of security. But how we prove this thing? This thing we already modified. Okay, so then we implemented this thing into the two platform. One is in our desktop computer as well as in our Raspberry Pi, and using our Java. Java is in the programming language. Okay, then individual operation. So in the security purpose, we are using the symmetric key concept. We can use the asymmetric key concept. So here in this experiment, we are using the hybrid concept, symmetric and asymmetric key both. Okay, so these are the cryptographic algorithms. Just I mentioned the blockchain is basically using the public key cryptography concept. Okay, so here, so that's why we implemented this thing using the Java platform, and we calculated the individual operation wise what is the execution time or basically the computation cost in the form of the Raspberry Pi. This is the lightweight IoT devices, and we assume this is the IoT devices and this is our desktop. So desktop is on the performance is too high, and but here in the case of IoT devices it is the lightweight devices, resource constant devices, that's why the computation. So individual operation wise we executed in the IoT devices, we write the program, we implement this thing, and then check the execution cost for the for individual operation. Okay, then we check the literature, and in the literature these are the schemes are there. but these schemes are only the security scheme. They also not provide you the blockchain based solution. Okay, they only provide you the security related solution, and we check that in the security purpose they are also using the some existing this type of operation. So we identified the what are the technique they used. Okay, in the literature these are the scheme name schemes. Okay, these are the reference name for this scheme, and these are the ongoing, and some of the countries they implemented this scheme. Okay, so then we check the individual these are the communication, storage, and computation cost. Okay, so we calculated from the literature and from their scheme. So these are the this type of operation they are using, and they also provide the some level of the security. So then this is the performance related parameter. So we measure the performance. Okay, so and then here we calculated the in the case of blockchain, and we are using this type of operation. Okay, and which is relatively very less compared to the all this existing scheme. So like here this is the basically computation cost. So this our scheme is, and the computation cost is relatively very less, okay, compared to the all this thing, and based on the two type of implementation on board as well as the Raspberry Pi. Same thing for the your energy consumption also in our scheme is less using the blockchain. So then, and as well as the we storage and communication cost also the relatively less. And so then that's why we prove that we using the implementation, and based on the all literature and based on the already implemented system, our system will provide the blockchain with the modification of the consensus algorithm, with the modification of the inside the your smart contract. Okay, so then we also compare the our scheme is not only the this thing the performance wise good. We check the these are the in general attacks is possible during the when the you communicate with the other guy in the open channel. Okay, so we prove this the our schemes is then the satisfied the all these attack protected from the all this type of attack. So that's why this using the blockchain in this case we can implement it the techniques, and this techniques is then the responsible for the efficient in the terms of different parameter performance parameter like the communication, computation, and storage cost, as well as the efficient in the terms of security. Okay, so this is the so here, so that's why that we designed the scheme based on the blockchain based scheme. This is the lightweight authentication and efficient communication, as well as the also provide the high level of the security, different types of the security attacks, and as well as the it is performance in the terms of computation, communication, and storage. So in general there is the blockchain based concept. Here we are using the public blockchain, okay, Bitcoin, and we modified the smart contract and as well as the your this thing in the your consensus algorithm. And consensus algorithm is basically reduce the consensus delay, and which is reflect in our performance in the case of execution. Okay, so these things we can implement, and in this case block generation purpose we are using the this is the steps for the any when we create the new block. So we follow the this process only. Okay, so this is the basically our this steps. Okay, so create the new block, and block means in our case basically this is the transaction. Transaction means when we when the any IoT device want to join into our network. Okay, so this is the overall idea, and if you have the any question, any query related to this, then otherwise I'll explain the what are the benefits for this this area, and how we think what are the basically opportunities in this area.
Sir,
Yes. Yes.
I am Anirban Kanungo speaking.
Yes.
Sir,
Yes.
sir, it was a very illuminating presentation about technology. Sir, I am just telling you when we are teaching this, if we have to teach this subject in class, okay.
Yes.
I am a professor at Bharat College. So, sir, what approach should we take, sir? Normally, should we give some programming
Yes,
sort of
yes. So in general, yes, yes. In general, two types of teaching is there. One is on the only theoretical concept you can explain, and second
Yeah.
one is on the you can follow the. In general, here we have the course, the blockchain and its application. Okay,
Yeah.
so course title is blockchain and its application. So here our objective is we don't have the lab component for this course. You know, the elective course. So in general, we don't have the lab component.
Yeah.
Okay, elective course means only the theory and lecture and tutorial. There is a possibility. So in general lecture. So here basically we in general we basic understanding and basic classes we started with the foundation of the blockchain. Then the all these things like how they implement the public blockchain Bitcoin. Okay, and how they implement the your this thing the this blockchain, and inside the blockchain different parameter like the your smart contract. Okay, proof of stake, proof of work. Okay, how they modified and modification, what type of modification is required. So all this implementation we are during the class hour, or we can conduct some small means lab hour or something for this all implementation. So initially we discussed the theory, and parallelly also we concentrate as a homework or as an assignment, as a lab experiment or something like give them the this type of implementation. Okay, so parallelly then which is basically helpful for the implementation, and also the some of the codes and some of the logic, all these things are available in the online. Okay. But my concept is if you follow the Python is for the implementation of the blockchain, which is good. Or you can use the other language also. No issue.
Okay, sir. Thank you, sir. Thank you very much, sir. Thank you very much. Okay.
But not only theory, if you implement the then student also interested, and also companies also want the like the practical idea. Okay, so that's why it is good if you focus on the practical thing. Okay, in the terms of assignment and quizzes, yes.
So, sir, in your institute, you said the assignments mainly they were based in Python language. They have to program the.
No. Initially, we mentioned that we don't have the anything constant. You can use any language. Okay, but if you focus the Python, then which is good because Python have the large number of packages and it is easy to implement.
Yeah, sir. Another thing is that, sir, you shown quite a few results which are based on Raspberry Pi and all these things.
Yes. Okay. So, sir, but here in this implementation, we are using the Java as a platform.
Okay. Sir, here you have actually designed. I think you have designed a prototype for blockchain application, right?
Yes. And we modify all these parameter and we modify the security algorithm.
Okay. So
because we only just explain the security concept, and based on the security, what type of performance we achieve.
So you have to build up that infrastructure. That is that.
Yes. Infrastructure yes. Here
you have to build up the. You also have to build up the background security algorithm also, right?
Yes. So, background security means some of the existing algorithm also we already used, but in the top of this algorithm we also use some lightweight operation.
Okay.
Because if you directly use those algorithms, then the computation cost is too high, and we have the IoT means lightweight device, resource constant device. So that's why it is difficult to implement.
Yeah. Because while teaching this particular subject, that is, I have tried to introduce this subject to one of my MTech students. Okay, and the difficulty I was facing is that I am not finding a normal framework through which to follow to teach this particular subject. Okay, because for example, like C programming or like say like digital communications. Okay, there is already an existing framework that is people are teaching this for many years, but this is absolutely new. So, sir, do you have any video lecture for or course regarding that?
Yes, so we have if you check we have this syllabus, all these things, and we also follow some of the tutorial from the some of the online resources also available. So we sometimes we also follow some of the online resources, but resources are only theory. Okay, so implementation you have to think. Like we categorize the implementation, like we categorize around 10, 12 assignment or something like that. And we give the assignment to the student and they implement all this assignment. And TAs in the class, TAs basically help them for the implementation if they are having some doubts or something like that.
Okay. Okay. Thank you, sir. Thank you. Thank you, sir. Thank you very much.
So any other audience, any questions?
Audience, if you want to post question to Debasis sir, you are most welcome.
Otherwise, just I'll explain this opportunities. Then after that, we can take some questions. Or okay. Yes, please. Yes. Yes. No, anything like you are from the electronics background. Okay, electronics thing. So electronics have the large number of opportunity on the smart grid. Okay, so smart grid, yes. So why smart grid? Because the smart grid, if you know that smart grid means they have the transaction on the smart grid. Means smart meter is there, and smart meter is collect the reading from your household or from any organization. Okay, then you transfer means what is your total number of the uses or something, or what is your surplus energy. So like blockchain, we can solve this problem. Okay, so that's why like the blockchain transaction is under like all, because large number of smart meter users are there, means all houses have your smart meter thing. So if they somehow through the blockchain we can implement some concept like where the utilization of your means total this energy, and based on this we can if somehow you already means you initially assigned around 250 meters, okay, 250 units, and you only spend around 200 units, so 50 unit just wastage. So this 50 unit you can share with the blockchain network, and other participant can they want to buy or something like that. So similar type of also work also available. Okay, so like you have to generate the solar energy from the solar plate. Okay, so then you generate the 250 units, but in your case now 250 units is enough, means only you utilize the 100 units. So 150 units is you want a surplus thing. So you can share this thing into the blockchain network, and any participant in the blockchain is on the open network. Any participant can join, and if he interested to access those energy, so they can this thing. So in this case, we can use the reward penalty type of concept. So in your case, you achieve the reward because you want to share some surplus thing. Okay, and who want to use this thing is and give you some benefit in the terms of penalty. So like this type of concept we can use in the case of a smart grid transaction, basically, not generation, smart grid transaction. Okay. Yes. 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 For a student, it is learning. But if you want to, so like, if you want to apply something in the real life application, so just we proposed one project from the government of India, like for the banking system. Okay, how we implement the blockchain concept for the banking system, means financial technology, not only banking, then your share market or other thing, where the large number of participate, and here the main important parameter is the financial thing is there. Okay, so here we basically our concept is somehow we design modify the existing blockchain network, existing blockchain protocols, all these things, and we modified based on the requirement wise bank. we design the new protocol. And we use those protocol, this new modified blockchain thing in the case of our Bitcoin. Bitcoin is on the transaction. There is a possibility in a second they perform 6 to 7 transactions. So it is very slow process. So we design something in the top of this modified existing blockchain. In a second we perform the around 1000 transactions. Okay, so it is more faster, and in banking system it is a faster is important because there is a no attack, there is a no fraud, so that's why. So like this way you have to think that what type of modification is required for your application. If your application is banking, then different type of modification. If your application is smart grid, then some modification is different. And also in student point of view, first they understand what is the concept of blockchain and what are the public blockchain platform is available, what are the private blockchain platform is available, and how we in the which application what type of blockchain is important and how we implement the blockchain. Basic idea. Then after that, if you have the time and if you're somehow you have something, then you can explain then how we modify the blockchain. Okay, in the terms, yes. Yes, yes. 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 Our system, all this as well as just I implemented in the Raspberry Pi. So you know the Raspberry Pi is very lightweight, but this implementation is possible. Okay, but there is a possibility more energy consumption, something is there. Okay, but somehow you can implement the everywhere. So our traditional system also you can implement, and nowadays also you can implement using the virtual cloud platform. Also there is a possibility. If you access with the some of the free access of the cloud, then you can implement the blockchain network. Okay, but here we basically student they implemented on their own laptop. Okay, and they create and they apply into the different application. Okay, then if we have the time, then they also modify the some of the parameter. But modification is difficult within the 6 months. It is difficult. But MTech and PhD student they implemented they modify the network and they apply it into the different applications. So, any more question from the audience? Okay, so just quickly I explained that what is the opportunity. So my specialization is basically the network and communication, and as well as the security and blockchain. So these are my ongoing project from the different organization, DST, MHRD. Okay, so this project is based on the security as well as the blockchain. So for the society, basically for the transportation, from the smart cities, for the and different application like the your smart grid. Okay, so these are the ongoing project, and this project is basically we implemented some prototype as well as a test bed for the society, and which is done the basically is ongoing. So means we initially modify design something test bed, now we modify. Okay, and we also installed on the some of the places in our nearest places in the city as well as in our campus. Okay, so this is the basically my objective is somehow how we modify how we enhance the something society related, so society benefit. So some research which is based towards the society. Okay, means my research is focused on mainly on the secure communication and networking, and I am looking forward to focus on the research area, extend the availability and usefulness of the technology and advancements to our society directly, and then which is enhance our quality of living. Okay, and these are the organization is any student and any faculty want to work on the blockchain, they have some open call for the blockchain or security as well as the cyber security. They can submit the proposal. Okay, here for the faculty, sometimes the PhD is required, sometimes the PhD degree also not required for the funding, so they can submit the proposal. And student also have the student project with the help of the faculty student, also BTech for third year or MTech student or PhD student also they can submit the proposal. Okay, and for the funding, and they can create some test bed or some real life implementation. Okay, so and also these are the market opportunities just I explained. And if they select and if they want to do in the blockchain and related field, so these are the basically career opportunity in the computer science and engineering department, as well as the your electronics if they are working on the blockchain. So they have these are the type of the jobs: software engineer, security engineer, cryptanalysis, data analytics. And these are the universities also working on the security as well as the blockchain. If any BTech student or master student want to do their MS or PhD, so they can apply there if they are interested in the blockchain area. Okay. And so in general, in the future trend, not only blockchain, as well as these are the research area ongoing: blockchain, smart grid, 5G, Internet of the Things, and quantum computing and communication. And here in the blockchain technology, these two things is mandatory. Any programming language, you comfortable with any programming language, C, C++, Java, Python, or data structure, basic idea about the data structure. These two things is mandatory when you implement the any blockchain. Okay, somehow you have any programming language idea, but basic understanding about the data structure, because when you implement something new idea, so data structure is mandatory. And other area, if you have the idea, good, otherwise not required. So these two things is under required. Okay, in the case of blockchain implementation. Okay, and we also have this opportunity for your BTech student. We are working on the blockchain area as well as the security, other machine learning, and multiple areas. So any BTech student, they are interested, they can directly apply through the online BTech internship at the IIT Jodhpur. Okay, and we also provide the financial support as well as accommodation, subject to availability of the accommodation. Okay, so this is the in general, we provide the 8 to 10 weeks, but sometimes it will be extendable up to 20-30 weeks also, based on the requirement of the projects. Okay, so that's it. And if you have any question, any query, you can directly mail me through this. Okay, and government have because in the most probably within the 6 months, there is an open call on the blockchain. Please you check from the government of the Ministry of the Electronics and Technology, Ms. METI. So they want to open a call on the blockchain. So anyone interested, and those who are working on this field, they can submit their proposal, and they have a huge number of funding and blockchain for the smart society. So multiple how the industry is benefited. So they are working on it. Most probably within the 6 months you receive the call, as well as the DST also there is a possibility for the one call. Okay, so government means multiple time government offer this thing open call for the blockchain technology. So you can, if you are interested, you can submit the proposal. Okay, for financial support. Thank you,
sir.
Yes.
Sir, I have a question regarding here.
Yes.
Sir, thing is that if some of our students who are very interested in this subject and who are very good in programming and all these things,
Yes.
if they want to have to apply for a internship with your group.
Yes. No, not our group. Here the open CSC department offer this internship, so they can apply through this online portal. Okay, and we receive the large number of applications, then we shortlist based on his interest. Okay. And sometimes we conduct the one-to-one interaction also.
Okay, sir, what are the features you look for in case of shortlisting students in that?
Okay, in general, after the 5th semester, what is the current CGPA? Okay, and he is comfortable in the programming or not, and we want the one SOP, statement of purpose, from the student. Okay. And also we focusing on the some of the student completed some minor project or something during the his BTech. So we also focus sometimes on this project also.
Okay, sir. Okay, sir. Thank you, sir. Thanks very much for this information. Sir, I will definitely ask my students to actively participate in this process. Okay, thank you, sir.
Any questions from the audience?
From
this talk?
Because next session is already going to start. So Dr. Raju Halder, sir, is with us. Okay, thank you so much, sir. See you tomorrow again. Tomorrow also, sir is having another session in the afternoon. So if you're having any queries, you can come up to sir tomorrow. Again, same time, 2 to 3. Now, I request Dr. Amit Agarwal, sir, to introduce our next speaker of the session, Dr. Raju Halder.
Good afternoon once again to all the participants. Let me have the privilege of introducing our second eminent speaker for the day, Dr. Raju Halder. He is a professor. He is assistant professor at IIT Patna, working there from December 2012. He was also researcher at HAS lab at University of Minho, Portugal in 2016. Prior to his journey at IIT Patna, Dr. Halder was a postdoc researcher at Macquarie University of Australia and University of Italy in 2012. Dr. Halder completed his PhD in Computer Science and Engineering from University of Italy. He did his Masters in Technology and Bachelor in Technology in Computer Science and Engineering from University of Calcutta in 2007 and 2005 respectively. He has completed a project titled Information Leakage Analysis of Database Query Languages from BST Government of India. He also has an ongoing project titled Development of Lizard-like Robotic Spy Surveillance System under Imprint 2, SERB DST and Government of India. Dr. Halder has guided one PhD student and currently guiding 9 PhD students under his mentorship. He is a member of IEEE and ACM SIG Soft. He is a renowned general reviewer of some very famous journals like IEEE Transactions on Dependable and Secure Computing, IEEE Transaction on Industrial Informatics, IEEE Transaction on Knowledge and Data Engineering, IEEE Transaction on Reliability, Springer Artificial Intelligence Reviewer, IIT Signal Processing, and IIT Information Security. So, sir, we welcome you all. We welcome you in our session. So, you may proceed, sir. Thank you so much, sir.
Thank you. Am I audible?
Yes, sir, you are audible.
Yeah. Thank you, Dr. Amit Agrawal, for your introduction. First of all, I would like to thank BIET for invitation. Special thanks to Dr. Anirban Kanungwe and Dr. Papia Datta. Well, so when I came to know that most of the audience people will be from student side, so I thought that, okay, why not to put very basic information about blockchain technology so that after having this session, students can get basic fundamentals and of course that will help students to gain some interest in this domain. So that's why I put most of the very basic information about blockchain. And of course, I agree that our first speakers, Dr. Debasis, he has given very nice introduction about blockchains. He has already mentioned about very crucial perspective of blockchains. And I'm sure that many of the content from my talk will be, will overlap with his session. But of course, I think both will be useful for all of you. Well, so let's start with basic things about blockchain technology. And one more thing that if you feel, if you have any questions, query, please feel free to interrupt me. Well, so let's start with one example that you know that most of us already have used credit card and all have done some kind of online banking transactions, right? So suppose I want to purchase something from Bob and I want to use credit card for the payment. So what I do normally, I will give my credit card information to Bob, and then Bob will get money from that credit card company, and later I have to pay that money to the credit card company, and I'll get 50 days time, something like that. On the other side, if I want to purchase something from Bob and I want to do banking transaction, what I have to do? I already have some account and some deposited money in my account. So I'll request my bank to pay the money to Bob, and then bank will do that payment on behalf of me. So in both these applications and payment systems, you understand that there is involvement of some third party. In first case, you have credit card company. In the second case, you have bank. Now my question is that whenever it's my money, I'm transferring my money to some seller or someone else, or to my friend. So why I have to be dependent on any third party? When any third party will be involved, of course, there is some kind of, trust issue. Of course, I have to provide some kind of charges for their services. That is extra thing that I have to give to that third party. But in addition, some kind of trust issue is there. Recently, you have heard about, Punjab Maharashtra Bank. You have heard about that Yes Bank. There is a lot of news in the media. And people who have, the the accounts in that banks, they were really in panic situation, because if bank won't be able to pay that money back, it will be really a difficult thing. So crore of money the customers will not get back. So in that case, it's your money, why you are dependent on that party whom you may not trust. So therefore, can we have some kind of situation, can we have some kind of technological solution which will help to remove all these untrusted third parties in between in the system? So therefore, for example, in this case, what I can do, I have, I have my laptop, I have my internet connection, I will connect my laptop with the internet, and then I'll click the button and my money will be transferred to my friend or to the recipient. So I can pay the money directly to the recipient over the internet. So everything I have. So there is no need to have involvement of this any third party. So that's the objective of this blockchain technology. And even sometimes when I do money transfer from abroad, of course you have to be dependent on Western Union or some other organizations. And of course, based on the money you are transferring from abroad, you have to pay them some kind of service charge. But if I go for blockchain-based solution, for example, Bitcoin, of course, you have to pay nominal charge. Even sometimes you don't have to pay. It depends on the amount. So therefore, this is the open questions that, is it possible to create some money in digital form without having any centralized authority like bank? Is it possible? So that was the open questions till 2008. But after 2008, that problem has been solved, and it was introduced by Satoshi Nakamoto through this that white paper. And this paper was not published in any formal conference or journals. It was communicated to a community through email. But unfortunately, that there is no person actually exist with this name Satoshi Nakamoto who can propose this Bitcoin. So whoever proposed this Bitcoin, actually he has used a different name, and he has kept his name completely hidden from the world. Still, today, we don't know who is actually Satoshi Nakamoto, who has actually proposed this Bitcoin paper. But at the same time, with this proposal, Satoshi Nakamoto, that guy, also made some reference implementation available on the source code platform, open source platform, and he has maintained that source code for 3 years, and after that, suddenly he disappeared. And today, if you look at cryptocurrency, Bitcoin is one cryptocurrency that was first introduced by Satoshi Nakamoto, and today, if you look at the market, you can find more than around 4,000 or more than 4,000 cryptocurrency in the market. Bitcoin is at the top. Then second popular is Ethereum, but it may vary based on the demand in the market, supply demand kind of thing. Well, so I have started looking in this technology in beginning of 2019, and that time the one Bitcoin cost was that, and suddenly, and today if you look at the Bitcoin price, you can find that it's a huge difference. So you can understand the demand of this cryptocurrency in the market, and the popularity of the Bitcoin and popularity of this blockchain technology also. Now, as already Dr. Debasis already mentioned that the technology behind this cryptocurrency is blockchain technology, and cryptocurrency is just one kind of applications of that technology. So when we look for blockchain technology, it's powerful enough to be applied to different kind of applications. As Dr. Debasis already told about that, this could be applicable in case of smart grid, in case of smart city, smart vehicular network, wherever. Similarly, it could be applied in IoT security, supply chains, medicals, healthcare, copyright protection, smart agriculture, smart grid, cryptocurrency, e-commerce, e-governance, everywhere, asset transfer, finance, everywhere. Even you can find a lot of new applications where you can apply your blockchain technology. It's not exhaustive list. So, and this is, of course, along with other technology like AI, machine learning. This is also one thrust area now in recent times, and it will be in the top 10 technology in the years to come. Of course, there are certain issues like scalability issue. There are various issues, interoperability issues are there, but lot of researchers are working in this technology, and I am hopeful that very soon a lot of solutions will come out, and this technology will be, applicable to any kind of complex systems as well, and it will be matured enough very soon. There's a lot of initiatives already taken by Indian government, state governments, and I have just collected few of them. There are a lot of startup companies already started in India, and so just to give you a overview that okay how this technology is trying to make changes in our life and in our society. Well, so when I go for this blockchain technology, of course, if you start learning about blockchain technology, three things most important. One is that the left hand side, that shared ledger, that what is the data structure, and how the information will be stored in that data structure. So that information you have to know. Second is that whenever you are dealing with some data in the blockchain network, so of course security is one concern, privacy is concerned. So cryptographic concept should be there. And other thing is that that there is a number of different parties involved. It's not a single party. It's not centralized. It's decentralized or distributed completely. So a number of parties all over the world. If I go for public blockchain, or if I go for private blockchain, maybe number of members or number of stakeholders within an organization may participate in the network. So it's a distributed network. So of course, whenever something happening, some activity happening, there should be some kind of agreement between the parties. Otherwise, it won't work. So whatever happening, there should be some kind of decision-making process, and there should be some kind of agreement among the parties, so that it will work as expected. And this is called consensus algorithm in distributed settings. So these three things most important. Now let me go towards little technical things so that you can understand the basic concepts. So about hash function, that given any domain having any size of input string, you can apply some function which will map to some output of fixed size. And this function is called hash function. This is mathematical function, but one thing should be remembered, that this function should be very efficient. But remember, the input domain is very large, but the output codomain, the codomain is small. So it is obvious that some of the strings will be mapped to a common string. So collision will always happen. That you already know in case of hash function. So this is one example. Of course, this hash function is not good enough. It's not secure enough, but still for illustration purpose, I have put it here. Suppose the hash function uses this modular operation, mod 26. And now if this is the input, then what you can do, you can apply the hash function. In the hash operation, what you have to do, you have to get the numerical representation of all these character, and then you apply mod operation, and then finally you get some output. It's some output. So it means that, okay, this is the input. Oh, actually, sorry, I am actually trying to highlight this mouse pointer, that's why. Okay, so this is the input, and after applying this hash function, you get some output, and this output is fixed size output. Okay, so if I go for this kind of hash function, you can find that although I can take two different input, x is one input, y is one input, but if I apply this hash function on these two different input, but the output can be same. So it means that it's a kind of collision. But of course, we have to consider one such hash function which is efficient enough, and of course, it should have less probability in collision. So what are the properties of this hash function is that once I get this hash value, suppose this is the input, and after applying hash function, I get this output. So this is called hash value. If I give this hash value, you cannot get back the original input. So this is one-way function. And another is that Okay, for two different input, you can have same hash value. This is a kind of collision. But if I have one hash value and one input, it is very difficult to identify another input which will lead to the collision. Or if I give you one hash value, it will be very difficult to identify a pair of strings, different strings, which will lead to same hash value. This kind of situation, this kind of identification is very difficult. So this is the thing that this is a property of hash function, that although collision exists, but probability is very low. And another very interesting property of hash function is that you can understand that if I have this input and this input, what is the difference between these two inputs? Only one character. You see, here you have V, but here you have U. But if I apply the hash function, you can understand there is a significant change in the output. What does it mean? That if I modify some small portion of the input, output will be significantly affected. So these are the properties of hash function. Now, using this hash function, I can construct some kind of data structure. So you know about linked list. In the linked list, you have various nodes, and in nodes, you can put some kind of data and also a pointer. This pointer will point to the previous node, suppose. Right? Or, okay, this pointer, okay, in linked list, this pointer will actually point to the next node. Anyway, so you use the concept of pointer. But here, we use pointer, but not only pointer, we use here hash pointer. What is the difference between pointer and hash pointer? In case of pointer, you are just considering the address, memory locations, memory address of any other value. But here, you are considering not only the memory address, but also the hash value of the target. Suppose this is your data in the memory. So your hash pointer will contain the address of this data as well as the hash value of this data here. So together it's called hash pointer. So if I make use of this hash pointer, I can construct this kind of data structure. What does this data structure look like? Look, so this is if I consider, if I compare with linked list, I can tell that, okay, this is a node, this is another node, and so this node is pointing to the previous node, this node pointing to the previous node. Now, what is happening if I look at linked list? Here, I should have the address of the previous node only. But no, in this case, I am using hash pointer. That means not only the address of the previous node I am storing here, I am also storing the hash value of this previous node. Similarly, I am also storing the address of this node along with the hash value of this node here. And this way, this whole data structure is being constructed. Now, what is the benefit? Now I can ask audience, can you tell me if anyone wants to modify a portion of the data in the first block? So in this context, I'll call it block, okay, not node. So if I call it block, if anyone wants to modify some data in a block, so what will happen? Can anyone suggest me? Okay, so maybe, yes.
We have to go through all the nodes and then reach that block, and then we have to change data in that block.
Exactly. So if I want to, so suppose I am attacker, I am going to change some data here. So what will happen if I want to go for changing some data here? As I already told, if you want to change something here, see, if you want to change something here, the output will become significantly changed, right? So similarly, the hash value will be changed actually significantly. So therefore, if I change something here, the hash value of this block will be changed. So if hash value of this block is changed, so it will affect this hash pointer, right? Because I have already stored the hash pointer before. Now, if I am going to change some data here, of course, this will change the hash value. So this new hash pointer will not match with the previous hash pointer. So it will affect the previous hash pointer. Similarly, if the hash pointer is getting changed here, so again, the hash value of this block will be changed and it will affect this hash pointer. And if this hash pointer is changed, this hash value also will change and it will affect the root hash pointer. So you can understand, if anyone wants to modify any portion of the data in this data structure, the whole data structure will become invalid. because you are maintaining the hash values in every link, right? So therefore, you can say that this data structure is tempered evident. No one can temper any data. So this is called blockchain. So this is nothing but a chain of blocks, and blocks are chained through hash pointer. So this is the whole concept of blockchain data structure. Now, of course, this blockchain data structure can be, compared with physical form of ledger. For example, you use, SBI Bank gives some kind of passbook, and you go to bank and you update your transactions in the passbook, right? So similar thing will happen in case of blockchain in digital form. So you can understand that passbook. So there are a lot of pages. So similarly, each block can be compared with pages. So here, one block is equivalent to one page. So if in your physical ledger, the transaction information will be printed, so in your blockchain, in one block, some transactions will be stored. And all these pages, somehow, there is a binding, right? So similarly, all these blocks somehow chained. So this is, you can compare with the bindings. And if you look at any passbook page, so you can find, okay, whatever information you have in a page, some metadata is there. For example, page number, some kind of maybe if you look at book, some kind of chapter number, some metadata is there. Similarly, in every block, you will have some kind of metadata, and you will have some kind of actual transaction. So this way, there is a complete similarity with actual physical form of ledger with the digital form of ledger, which we call blockchain. Now, as I already told, that we don't go for centralized system, because centralized system is very vulnerable. It's not trustable, because every the server will be here controlled by some person, individual person, and you cannot trust him. He can do any kind of modification of the data stored in the server. So whoever users are going to get service from the server, so they have to connect to the server, they have to send a request, and the server will provide the services. But of course, the issues are that, of course, it's not reliable. The connection may fail, the server may fail, and it's not trustable, because one administrator will be there who can modify the data illegally, illegitimately. Okay, so therefore, centralized system should not be trustable enough and reliable enough. So we have to go for decentralization. And you know that decentralization, you can see, you are using, for example, Facebook, Google, everywhere you can find decentralized. They are not using single server. They are using a number of servers, and this spread over all the world. And what is the benefit? You never experienced any kind of server failure, right? So maybe some server, for example, this server may be failed, but users cannot experience this. Because when this server will fail, all the associated users can get services from another server deployed in another location. So this is the way that decentralization will give more reliability in the whole system, as if there is no failure. Okay, so therefore our target is that from centralization to decentralization, movement to decentralization. But here, another point is that all these servers, if I look at Google, all these servers actually are controlled by Google. All these servers are controlled by Facebook. But of course, as a person, as an individual, I do not believe Google. For example, I do not believe Facebook. It may happen. Because when I am dealing with some kind of sensitive data, I, of course, not opt for Google Drive. Because I will have certain kind of, doubt that, okay, if I keep it Google Drive, in the Google Drive, someone can get it. So I do not believe it, actually. So therefore, we have to go towards some kind of, completely distributed systems where, everyone will have, there is no difference between nodes. Everyone is acting as server, everyone is acting as client. There is no difference in the node, and all are equally powerful. So now let me give one case study, just example that how the whole blockchain works through this this example. Okay, so I cannot remember when I have started, so please let me know when the time will approach. Okay, well.
Sir, no problem. You continue. You are explaining very beautifully.
Okay, thank you. Well, so let me explain the working principle of blockchain technology by using one case study, Bitcoin. So you know that you already heard about Bitcoin, and even many of you already joined Bitcoin network, that I guess. So you know that there are a lot of people all over the world, they are connected in this Bitcoin network. So this is nothing but distributed peer-to-peer network. Now here, suppose this is the existing Bitcoin network, and where many nodes are there, computational nodes are there, and suppose I want to join this network. I got some interest in Bitcoin. I want to make some kind of transactions in Bitcoin, and I want to join this Bitcoin network. I'm curious. So what I do, this is me. There are some specific nodes which we call seed nodes, and this seed nodes address is known. What we do, if I want to join, I have to send a request to the seed node, asking him that please give me the address of your neighbor because I want to join the network. So what this seed node will do, because seed node has the neighbors 1 and 7, right? These two are the neighbors. So this seed node will provide the addresses of these neighbors. That means 1 and 7. Okay, so after getting these neighbors address 1 and 7, then what I will do, I will contact 1 and I will contact 7, and I will request them again the same request, that I will contact 1 and I'll ask 1 that I want to join this Bitcoin network, please provide me the address of your neighbors. And I will contact 7, I'll ask 7, I want to add the network, please give me the neighbor address. So similarly, I'll make the request and I'll get again the address of the neighbors like 3, 2, 6, all this. And similarly, I will repeat this process as many times as I like. And finally, I will get connected few of the nodes. I mean, it depends on me how many nodes I want to make them neighbors. Okay, so this way a node can join Bitcoin node, Bitcoin network. I mean, distributed peer-to-peer network. Well, so when we are part of this distributed peer-to-peer network, now next thing is that I have already talked about blockchain structure, right? This is the blockchain structure where the actual transaction information will be there. So let me go to this figure now. Yeah. So now, if I talk about Bitcoin network, and if I tell you that in the Bitcoin network there are 100 people, suppose, for example, so all the 100 people will have the copy of the blockchain. Everyone will have the copy of the blockchain. See, in this figure there are 4 users, so all those 4 users or 4 nodes should have the copy of the blockchain. Now the crucial point here is that I understand that everyone will have the copy of the blockchain, but what will happen if some new information to be added into the blockchain? Suppose this person wants to add some new information in this blockchain. So we have to make sure that if some information to be added in this blockchain copy, the same information should also be added in all the other copies. It means that the information in all the blockchain copies in the network should be consistent. There should not happen that some more information there in few blockchains, but in other blockchains, those informations are missing. Okay. Maybe some kind of we can do some kind of toleration. I mean, I can tell that, okay, we can tolerate some kind of discrepancy. It depends on the attack model, but we expect that all the copies, ideally, we expect that all the copies of the blockchain should be consistent. All the information should be up to date. Now, that will be done by using consensus mechanism. So there should be a consensus mechanism through which all the parties will agree to have same copies of blockchain. It means when a new block, if I call it block, when a new block will be added to this blockchain copy, the same block should also be added to other blockchain copies. So that is the consensus mechanism. I'll talk about that. Now let's give very simple example that why we are going for this blockchain. It looks very difficult now maintaining this blockchain copy with all the people in the network. I mean, I have a simple laptop. Can my laptop support the storage of whole blockchain copy? Just those kind of questions can be in my mind. Or can I use a mobile phone to store the blockchain copy? Because using mobile phone, I am connected with the blockchain network. So my mobile phone is acting as node. So will it be, I mean, is it possible to store the whole blockchain copy in my mobile device? So those kind of questions can appear. Okay, let's see how blockchain can help to bring trust and transparency in the network. Suppose in the network, there are only 4 people, Alice, Bob, Jane, and Eve. And initially, in the blockchain, so all will have the blockchain copy. So in the initial blockchain copy, this only single information is there that Alice has only 100 rupees, suppose. So, and that information is there in every blockchain copies. Suppose Alice wants to transfer 50 rupees to Bob. So this is a new transaction, right? And this new transaction should be initiated by Alice. And now what Alice will do, after creating this new transaction, Alice will broadcast this transaction into the network. I am repeating, after creating this new transaction saying that I want to transfer 50 rupees to Bob, this transaction should be broadcasted into the network by Alice. Therefore, all these other participants in the network will receive this transaction. And now, when the new transaction will be received by Eve, then Eve can check, okay, in the actual blockchain, in the previous blockchain, in the initial blockchain, Alice has 100. Now Alice is going to transfer 50 rupees to Bob. So this is perfect. There is no issue. Jane also will determine that. Bob also will check the validity, something like that. And all agrees, no? All agree that, okay, whatever transactions Alice is going to make, it's valid. There is no wrong thing. So therefore, everyone will accept that information and accept to the and add it to the blockchain. So I just assume that this is a new block, huh? And every block contains single transaction for the time being. Of course, in real practice, I mean, one block can contain thousands or more than that. I mean, a number of transactions, not a single transaction. Well, so this is done. Next, suppose Bob wants to transfer money to Eve, 30 rupees. Is it possible? So Bob will broadcast this transaction in the network. Everyone will get this transaction information. Everyone will check the validity of the transaction, that what is there in the actual blockchain copy, and can Bob transfer 30 rupees to Eve? Of course, yes, because Bob has 50 rupees now, you see. So it's possible. So everyone will add this new information to their copy. And this is happening. The addition of this new information to all blockchain copies will be done through consensus algorithm. Well, so now suppose Alice is going to transfer 80 rupees to Jane. Is it possible? No, this is invalid. This is wrong transaction. Alice does not have 80 rupees. Alice has only 50 rupees. So she cannot transfer 80 rupees. So this is wrong transaction. So when Alice will create this new transaction saying that I want to transfer 80 rupees to Jane, and Alice will broadcast this transaction into the network, so all other parties will not accept it, because all other parties have that blockchain copies. They can check the validity of this new transaction. So they do not consider it. They will say, no, Alice, you cannot do it. So no one will accept it. So no one will agree it. So any wrong information, any wrong transaction will not take place in the blockchain. You can understand this is the power of public, I mean, the network users. It's not, the decision cannot be made by a single one. The decision should be made by all or majority. So that's why this gives the power of blockchain technology, and this makes this blockchain technology very transparent and trustful. So although in a system there may be multiple parties, I mean Alice, Bob, Jane, and Eve, if they do not believe each other, they are completely untrusted to each other, but this technology will bring trust in the system. So I have few questions to all of you, especially students. Yeah. So if I ask you, the first question, here ledger of transaction means blockchain. So who will maintain the ledger of transactions? I mean, who will maintain the blockchain copy? Any individual, any particular group, or all? Yes, good. All participants. My next question, how that would be maintained? I mean, how they can ensure that information in one blockchain copy is consistent with other blockchain copies also. I mean, all the blockchain copies are up to date with consensus algorithm, right? In Bitcoin, the consensus algorithm is known as proof of work. Okay, that I'll tell you what is proof of work. Second question, who will determine that whether a new transaction is valid or not? All nodes. In the previous example, I have shown that Bob, Zane, Eve, everyone can check the validity. Even Alice can also check the validity. So because the transaction after creation by the initiator, it will be broadcasted into the network. So everyone can check the validity because everyone has the blockchain copy. All the past history is there in the blockchain. So based on that, the new transaction validity can be determined. Yes.
Sir, I have a question.
Yes, yes.
Sir, actually, we have to store even these small particles of information about every transaction.
Exactly.
So I think, sir, we need memory, computer memory to
Yes.
store these things.
Yes.
But very fast, it will run out of memory, right?
Well, so it depends. So you know
Huge
that
amount of memory would be needed.
yeah, good question. So you know that currently, the Bitcoin started in 2009, maybe the first transaction, which is called what is called Coinbase transaction. Sorry, not Coinbase. The first transaction is maybe oh, I forget that name. Anyway, so it has been started in 2009 and almost 10 years.
Yeah. It is 10 years old at least.
So you can understand that currently the size of the whole blockchain, Bitcoin blockchain, I mean, the size of blockchain containing all Bitcoin transaction is almost near about 400 GB or something like that. So it's possible, no? That to store in the hard drive.
Yeah, but see, 400 GB is a small number compared to the number of transactions. But and still now Bitcoin has not yet been fully adopted by everybody. Okay, only speculators are. But if everybody tries to adopt that,
right,
then it would look a huge memory.
Yes, yes. So there is another concept that lightweight nodes maybe. Lightweight nodes, right? So in this case, rather than storing the whole copies of the blockchain, you can store whatever relevant to you only. I mean, part of the blockchain copies. That is also possible.
Yeah. Sir, we.
Yeah, exactly. Good. Genesis block. Exactly, Genesis block. Yeah. Sorry, I forget that name actually. Yeah.
Yeah. So is there any chance of offloading some of the excess, excess load? Because there is someone a small insignificant transactions, or there is nothing insignificant maybe.
It's very difficult. Anyway, it depends on the application. So, but there is that there is decentralized storage. For example, IPFS. For example, Swarm. Those kind of, when you are dealing with some kind of images, videos, or big size data. So in that case, it is not suggested to store it in the blockchain. You store it in some other place and you put the corresponding link, just link, not the whole data, just link into the blockchain. So this way you can optimize the thing. Of course, I mean, this is very relevant questions, and still people are doing research on this. So normally IPFS is being used very widely in this context, and what people will do, people store that images, all these videos, everything in the IPFS, and even IPFS, that public IPFS is also there, decentralized storage. Any students can also use that. If you search with IPFS, so there is one interface, you can use that. So if you put some information in the IPFS systems will return the corresponding hash value.
Okay.
And that if you, and then using that hash value, you can extract the information later also. So you just, after getting the hash link, from the IPFS system, you put that hash link in your blockchain for security purpose. I mean, so that way you can optimize.
Okay, sir. Thank you.
I agree with you. So there is a lot of things happening that of course transaction size we have to consider very small so that it should not increase out of our limit. And when we do computation in the main memory, so we have to have some kind of mechanism that we will take the relevant information into the primary memory and we do the computation and we put them back to the hard disk again in the actual blockchain copies. So that kind of optimization happening. Yes.
Okay.
So okay. Can you repeat the name? I don't know actually. Maxmin, right? Oh, Maxmin pool. Okay. Is it mining pool or? Oh, okay. Mining pool is another concept, of course. But how mining pool can help in this? Maybe I have to look at. Actually, I have no information. Maybe I'll look at. Oh, I understand. Unspent transactions cache. Yeah. Exactly. Yeah, I agree with you. Yeah, thank you. Okay, so you can understand here. So everyone can check. I mean, this is completely transparent system, so everyone can check because everyone has blockchain copies, and the blockchain copies contain all this previous history. So any new thing can be verified. So how to check actually what is the structure of this transaction? So that I can check this whether the transaction is valid or wrong. There is a very specific kind of scripting language and only dedicated for Bitcoin. That is called Bitcoin scripting language. I am not going to detail about Bitcoin scripting language and the structure of this transaction. If you have interest, you can go for that. Every transaction should have some specific format, specific structure. And there should be some kind of scripting language in the transaction. So when these new transactions will come to me, then using that scripting language, I can verify whether this new transaction is valid or not. Okay, that's just for your information. Well, and the last one is that who will create that new Bitcoin? How the new Bitcoin will be created? Okay, that thing I'll tell you when I talk about mining process. And that time, some kind of reward will be given, and that reward is the new money to be given to someone, and that is the creation of new Bitcoin. That I'll talk later. Well, this is now working principle. I will show it pictorially. Suppose so you have your mobile, you have your laptop, whatever, and you just install your client software. And the client software, I mean, it is just a wallet software. You know, wallet software, and this wallet software, we can manage your private key, public key, and can create the transactions on behalf of you, can sign the transaction. There is a requirement of digital signature. Otherwise, you know, your money should be used by yourself only, not by others. So your digital signature is required. So those kind of things, your wallet can help to do that. So after your wallet creates this transaction, you click the button. The wallet will create the transaction, will send it to your neighbor. Your neighbor will verify your transaction and will forward it to their neighbor. The neighbor of neighbors will again verify the transactions you have created, and again they will forward it to their neighbor. So this way, your transaction will be broadcasted into the network. This is called flooding. Okay, so after this transaction is being broadcasted in the network, all participants got your transactions information, right? And this is happening. So this is the way, you know, that you have created one transaction, you have broadcasted to your neighbor will verify that. If they find that your transaction is okay, they can forward it to their neighbors, and this way it will be flooded into the network. So everyone will get your transaction copies. So the next one, there are 100 people, for example, in the Bitcoin network. Suppose there are 100 participants. Out of that 100 participants, so you are also participant, I am also participant. So you are getting all the transactions, you are listening all the transactions broadcasted, right? I am also listening all the transactions broadcasted. So anyone in the network listening all the transactions broadcasted by different parties. But there are certain nodes which we call minor. And those minor nodes, what they will do, they have interest in something. They have more computation power, and they have some interest in doing something. So what they actually do, they consider some transactions they are listening over time, and they will create a block. What is blockchain? I have already told, it's nothing but chain of blocks. So in the blockchain, you have number of blocks. So this miner will create a new block, and a block will contain some metadata and some transactions information, right? So this is the information, this is the structure of a block. So the miner, very special kind of nodes. You can be also a miner. I can be also a miner. There is no restriction. Anyone can act as miner. But miner should have a lot of computation power. So what miner will do, whatever transactions miners are listening, they will consider those transactions into the block. They will put in the form of block, and they will put some metadata also. This metadata contains many crucial information. I am not going in detail of that, but you know that all these transactions actually not stored in sequential form. They will be stored in the tree-like structure. I mean, this is called Merkle tree. So anyway, some kind of structure is there, and the block will be created by the miner in this, following this structure.
Okay.
Now, of course, if I say that, okay, there are 100 people, but out of 100 users in the network, maybe 50 users acting as miners. It may happen at the same time. Or maybe 40 people acting as miner. So it means that all 40 people created this block at the same time. So now, can we consider all these 40 blocks at the same time? No, we cannot allow. Otherwise, there will be a lot of problem. So what I do, then all these miners who have created blocks, I mean all these 40 miners, they have to go for some kind of puzzle solve. They have to solve some puzzle. So what they have to do, this is called proof of work. Everyone will do some kind of proof of work. What they have to do, suppose I am acting as miner and I have created this block. In the block, I have considered a set of transactions I have listened, and I have created some kind of metadata. Now, here you can find what I have to do. Whatever block I have created, I have to apply some kind of hash computation. I will compute the hash value of the whole block. And as per the protocol, blockchain protocol, it is mentioned that whatever hash value you get for your created block, there should be n number of zeros at the beginning. What is n value? It may vary over time. Suppose at this time being, I mean now today, n value is 64. Suppose, I am just guessing. So if n value is 64, it means that I have created this block. I have to compute the hash value. Whatever hash value I will get, the first 64 bits should be zeros. First 64 bits should be zeros. So in this case, you can find, so what I can do, suppose first I have applied the hash function and I get some hash value, but it does not have 64 zeros. So I am not successful. So in that case, what I have to do, I can change some information in the block, right? Because you know that if I change the input value, then the output value will change. This is the property of the hash function. So if I change something in the block, then I can get another hash value having 64 number of zeros. Then I can be successful. So what I do, I will change the nonce value again and again. And if I continue this way, after certain time, I may be lucky enough to get a correct hash value having 64 number of zeros. And that time I am successful in solving the puzzle. So this is just the example. Suppose this is the actual blockchain I have. I am acting as miner. This is the actual blockchain I have. This is the new block I have created just now, considering a number of transactions. So what I have to do, I have to compute the hash value of this block. And if the hash value has 64 bits at the beginning, then I am successful. So let's see. I consider the nonce and I compute the hash value, and I find no, this does not have 64 number of zeros, so I am not successful. So what I do, I change the nonce value. You see, I have changed the nonce value. Then I compute once again. I'm changing the nonce values and I am computing again and again, but I fail. Whatever possible nonce values I can consider, because nonce size is 32. So I have considered 2 to the power 32 possibilities, but still I fail. So what I do, there is, you know, that these are the transactions I have considered in my block, and these transactions are initiated by other people in the network and they have broadcasted and I have listened. But this transaction is being created by me. Forcefully, I have added this transaction from my side. These are the transactions from other people, but this is the transaction I, as the miner, will include. So here, there is one field where I can put some value randomly. So now I will change the value in that random field, and then I will continue this process. And suddenly I'm successful. Because you know, whatever hash value I am applying over, if I change anything in there, the hash value will change. So therefore, if I change the information in the Coinbase, that will also affect the output hash value. So after doing this process again and again, suddenly I am successful. That means in the hash comp value, I get 64 number of zeros. So I am successful. In this case, I will add this block to my blockchain copy. I'm successful. I have added a new block to my blockchain copy. What about other people? Because I got one new block. So what I do, I will broadcast this new block into the network, and I will tell everyone, look, I have got a new block and I am successful in getting valid hash value for that block. That means whatever new hash value I have got this for my block, this has 64 number of zeros at the beginning, and I have put all this information into the block. You just check it. If you feel okay, you accept it. So everyone will check that what I propose a new block. It means that I propose a new block. I broadcast into the network. So everyone in the network will accept this new block because I have done correct thing. Right? So, and this way you can understand that everyone will accept my new block and all the blockchain copies in the network will be consistent. So this is called consensus mechanism, proof of work. Now, what are the steps that I told? First, you have to join the network. You have to listen the transactions. You have the complete power to validate all the transactions. I mean, there is no mandatory, compulsory thing. If you do not want to validate, it's okay. If you want to validate, it's also okay. It's up to you. Now, second is that if anyone is acting as miner, they will create a new valid block and they will find the correct nonce value in the block so that the block becomes valid. I mean, the required number of zeros should be there at the beginning of the block hash. And once this is done, this miner will broadcast this new block into the network. And then all other participants in the network will listen for this new block and will check this block and will add that block to their copy. Because I told that everyone has their individual copies. So when XYZ will receive a new block from a miner, XYZ will add this block to his blockchain copy. And most interesting thing is that profit. So question is that why I will do this mining process, why I go for this block creation and block validation, and I will broadcast into the network so that other people will consider this block into the blockchain. Because miner is actually adding information into the blockchain. Look, miner is responsible to add actual information in the form of block into the blockchain. So miner has a lot of power to manipulate the blockchain. If miner intentionally puts some bad information in the block, and that block will be added by other people, then blockchain will become invalid. I mean, full of wrong information. So miners have a lot of responsibility. So now miners should not do malactivity. Miners should be honest. So for that, they should be given some kind of reward. So how that reward will be given? You see, if I go back a little bit here, when miner is creating this block, these are the transactions created by other people, but this is the transaction created by the miner himself or herself. So miner in this transaction can put some information saying that, okay, this is the miner, give 25 Bitcoin as the reward to myself. This is the information miner can put in a new transaction. So if everything is perfect, miner is successful, then this 25 Bitcoin miner will get, and this is the creation of the new Bitcoin. You get my point? So this is the creation of this new Bitcoin, and this is called reward. And initially, when Bitcoin started, that time the reward amount was 50 Bitcoin. You can understand 1 Bitcoin is equal to 35,000 USD nowadays. So 50 Bitcoins initially reward was given to the miners. After 4 years, it becomes 25 Bitcoin. Then again after 4 years, it becomes 12.5 Bitcoins. Then I think this year, it has become 6.25 Bitcoin. Okay, every 4 years, it's getting half. And this way, this amount is being given as the reward to the miner, and this is the creation of the new Bitcoin, and miner can spend this amount in the market. Now, you can understand the total circulation of the Bitcoin is 21 million, and this way, through reward, that 21 million Bitcoin will be given to the miners. And in 2040, all these, whatever Bitcoins in circulation will be given to the miners as reward, and after that, there will be no money to be given to the miners. So after 2040, miner will not get any kind of block reward this way. So then why miner will get, we will do this block creation activity? There is another kind of money. So whatever transactions will be created by other people, they can also give some kind of tip. They can give some kind of tip to this miner. So that miner has two kinds of reward. One is that block reward, another is that transaction fees. Those transaction fees will come from these transactions. So after 2040, although block reward cannot be there, but miner can be dependent on transaction fees given by other transaction initiators. And this is the reward for their hard work, because they are doing hash computation again and again. They are doing proof of work. For that, they are investing a lot of power, lot of energy, lot of computational devices. So therefore, this is the reward for that, and to act honestly. Okay, so I think the whole working principle is clear to all of you. Now, I don't know how much time I have, but very quickly I can give you some other benefit of blockchain technology. So you can understand, if I look at the price of Ether and the price of Bitcoin, you can find there is a lot of difference. Bitcoin is 33,000 almost, one Bitcoin. But if I go for Ether, Ether is another kind of cryptocurrency, which is having market price 2042. But you know, today you have heard about Ethereum a lot. So why Ethereum is so popular? Why people like Ethereum? Let's look at that. So till time, I have just explained about Bitcoin. Bitcoin only for financial transactions, cryptocurrency transactions, not for any other purpose. Now I am going towards Ethereum. Why people like Ethereum? Let's see. Bitcoin can be compared with the old version of this, calculator. So you can just do addition, multiplication, all this thing, but limited number of operations using this. So you can think that, okay, Bitcoin can do only a limited functionalities and only financial cryptocurrency transactions, and the validity of the new transactions can be checked by every participant in the network, and there is one scripting language to do the validation checking, right? Bitcoin scripting language. But that Bitcoin scripting language is not Turing complete. It does not support recursion. It does not support iteration. So very limited functionalities it can provide. But if I go for Ethereum, Ethereum can be compared with like this kind of devices, smartphone. And you know, in smartphone, you have that calculator, as well as you have some other applications also that you can use. So therefore, if I move to Ethereum, Ethereum not only supports cryptocurrency, but Ethereum also allow you to develop a complete application. And since this underlying blockchain technology is completely decentralized, so you can call it decentralized application. Now, whenever you go for implementation, I mean developing any applications, you require some Turing complete programming language, right? Turing complete means it should support recursion, iterations, all these functionalities so that you can solve any problem, solvable problems. So like Java, C, C++, all are Turing complete programming language. So, but Bitcoin does not support any kind of Turing complete language. It supports only Bitcoin scripting language that is limited expressibility. When I go for Ethereum, it allows you to develop a complete decentralized application. So for that, you require some kind of programming language. You require some kind of compiler. You require some kind of execution platform, right? So therefore, first, I think 2014, Vitalik Buterin, he is actually a Canadian-Russian student, and you know the age, just his student, 19 years old that time he was. And that time he first introduced Ethereum, and he introduced the Ethereum as a blockchain platform, but this blockchain platform supports the writing of programs in Turing complete language. And to execute the program written or stored in the blockchain. So what he suggested that, okay, I have the blockchain, chain of blocks, but in the chain of blocks, rather than putting only the transactions, financial transactions, I can put also the small code program written in programming language, Turing complete programming language. And those codes will act as functionalities. I mean, you know, when you write some code in C programming language or C++, you have a set of functions, you have set of inputs, you have, the functions will applied on the input and you get some kind of output. So overall computation will be done by these programs. So similar kind of programs you can put in the blockchain, and that copy of the program will be in the blockchain, and the blockchain will be with all the people in the network, right? So anyone can execute the program in a decentralized manner. You don't have to send a request to the centralized server. I have the blockchain copy. If in the blockchain copy, there is one program code, I can execute the program code on my own system. Similarly, if the blockchain copy is in your system, the same code will be there in your blockchain also. So you can also execute some functions of that program. And those kind of programs called smart contract. So having this support of smart contract, you can develop a complete decentralized platform application. And what is the benefit? So you know that smart contract is nothing but a computer program that could be executed on blockchain, that could be stored and executed on blockchain, and that can control all these digital assets. So similar, so it's, you know that this is the high level. So one very popular language for Ethereum is Solidity. I would suggest all students to go for Solidity first. You will understand very easily because it's very similar to JavaScript. There is another one, Viper. Viper is not very popular, but the syntax is very similar to Python, but not very much popular till the date. But Solidity is very, very popular. So you go for Solidity. So this is the language, high-level programming language. So here you can find that, okay, I can declare some variables, I can write some functions, and the function will apply it on these variables. You can take input, you can give output, whatever you do in any programming language. You can write programs like that. You can compile it. You can get bytecode. In Java, you can get bytecode, right? The intermediate code. Similarly, here also you can get intermediate code. And those intermediate code, you can put in the blockchain. And the blockchain copy will be in every person, right? So every person will have blockchain copy, and the blockchain copy will have this code, and that's smart contract code. Well, so that I have told, this is the block, this is another block. You can have the code here, and you can have also some storage in the blockchain that will store the variable values of this code. I mean, in any program, there are some certain variables that you can declare. So those variables can contain some values, right? You can store some values in the variables. So those variables can be stored, variable values can be stored in this local storage in the blockchain, within the blockchain, and it is very costly. So when you do writing the code, you have to be very careful that, okay, this storage can be used in an optimized way. Now, what is the benefit of having this smart contract? One simple example, having this support of smart contract, the small code or program I can store in the blockchain and I can execute in a decentralized manner, because the blockchain network is itself in a decentralized setting, right? So what is the benefit? Benefit is that suppose there is sellers and buyers, and I have some e-commerce platform like Amazon, Flipkart. What Amazon provides services, you know, and Amazon takes some kind of charges from the seller also. So in this case, although Amazon is very popular, I believe, but if you want to create a new e-commerce platform from your side, can it compete with the Amazon? Can people, will people use your e-commerce platform? Never. Because people will not trust you. People will not trust your e-commerce platform. That's why, although you want to create one e-commerce platform and you want to compete with Amazon, you won't be able to. Like Ola, Uber, like insurance companies, suddenly you cannot do something. I mean, you cannot create and you cannot compete with them, because they are very big companies and they are centralized. They have centralized control. So what you can do, the blockchain can remove all this Amazon, Flipkart, all these things. And all these sellers, buyers, they can be connected through this blockchain network, and everyone will have the blockchain copies. And the blockchain will have that small code that Amazon or Flipkart performs. You know that what are the functionalities of Amazon, what are the functionalities of Flipkart. Similar kind of functionalities you can encode into the smart contract, and you can put that smart contract code into the blockchain. So what can be done? So buyer will call a function of the smart contract. There are so many functions. One function will accept request, another function will send money, another function will do, okay. So buyer wants to purchase something. So buyer will send request. So buyer will call a function of the smart contract. Function means program functions. C program has functions, Java program has functions. So buyer will send request, will execute a function, and that request will be sent, that buyer is requesting to purchase something. So that request will be sent to the seller by the smart contract automatically. So seller will get notification. Then seller will tell that, okay, for this product, I require this amount of money. So then the smart contract will inform the buyer that, okay, this is the money, this is the amount for this product. Then buyer will execute another code, another function, and some cryptocurrency will be transferred from buyer to the smart contract. Smart contract also have capability to hold money. I can have an account in my Bitcoin, in my Ethereum network. I can hold some money for me. Smart contract are the entities that can also hold some money. So buyer will send some money to the smart contract. Smart contract will not release this money now. What smart contract will do? Smart contract will tell the seller, look, buyer has given money and that money is with me. So now you dispatch your product, and once buyer will confirm, I will release that money to you. So seller will dispatch the product, buyer will receive, and buyer will inform the smart contract that I have received the product. Then only the smart contract automatically release that money to the seller. So you can understand the code is there. Although you do not trust Google, you do not trust Amazon, you do not trust Flipkart, but you believe the technology, you believe the code stored in the blockchain. So this way, the use of smart contract can remove all the intermediaries. Like any insurance company can be replaced by smart contract. Any Ola, Uber can be replaced by. So here is a very nice example. You know, Vitalik Buterin told, okay, so instead of putting a taxi driver out of a job, blockchain puts Uber out of a job and lets the taxi drivers work with the customers directly. Very nice statement. How that will help? How Ola, Uber can be ignored completely? Let's see. So there is rider, there is drivers. They are the users of the blockchain networks. They are connected through blockchain network. So there is blockchain, and all the smart contracts are there in the blockchain. So first, there is one function. Rider will call this function, will say that, okay, this is from this place I want to go to this place, and this is the number of passengers, and I want to get this kind of car. So this information will be executed. With this information, some functions will be executed, and based on some information already there in the blockchain, the estimated price will be computed somehow. Or maybe there can be some off-chain. If anything is in the blockchain, I would call it on-chain. If some application is outside of the blockchain, I can call it off-chain application. So the smart contract can contact with the off-chain application to get the traffic condition, for example. Based on that thing, the amount fare will be computed, and then information will be sent to the driver that this calculation will be done. Okay, this driver can be assigned, information to be sent to the driver. Driver will click the button and the acceptance information will be stored in the blockchain by the smart contract. I mean, smart contract is having a number of variables, and those variables are nothing but storing information. And then everything is done, and after final rides, rider can pay the money to the smart contract, and smart contract can pay that money to the driver, and there is also rating system. So everything can be done automatically by the smart contract, and there is no third party, and it is completely distributed. And once something is written in the blockchain or in the smart contract, this is permanent. No one can modify it. As I already told, this is temper proof. As I already told, there are so many applications, and this is the growing interest that in 2013 there was only 2 research papers. In 14, 4, 15, 21 research papers, and 2018 you can find the jump. And of course, today, in 2021, I don't have exact figure, but you can understand how many papers are going to be published day by day. It's going to be very competitive as well. If you go to Niti Aayog, you can find a very nice, framework that will guide you in what kind of application you should use blockchain, and what kind of application you should not use blockchain, and in what kind of situation you should use private blockchain, public blockchain, or consortium blockchain. So I hope that you understand. Maybe you can get information. There are 3 kinds of blockchain: public, like Bitcoin; private, like in an organization; consortium means between a number of organizations. So this is the layered architecture. I can skip maybe at this point. Okay. Finally, this is the last slide that for students, how to start. So I would suggest, if you want to gain knowledge in blockchain, you first go for Ethereum. And then in Ethereum, you learn about Get client. Then you learn about how to write. Using Get client, you can be able to accumulate some kind of virtual, hypothetical cryptocurrency called Ether, of course, but it's not real. And you can make some transfer from one account to another account. You can create a lot of accounts. You can create a lot of nodes. All these facilities are there in the Get network. I mean, you can create a new blockchain network by yourself, having a lot of users, lot of accounts, and you can make some kind of transactions, cryptocurrency transaction. Then you go for Remix IDE. The web interface is available. There you can write some program, smart contract code in Solidity language, and you can execute it using some kind of blockchain networks at the back. Maybe there are some kind of ready-made blockchain network, testnet, Gana sharing B, all these things, you can make use of that. You can go for learning some kind of wallet software. MetaMask is very popular. You can go for that. You can learn some programming language to write smart contract code. And I would suggest that go for Solidity first. And then you can go for these things, IPFS1. Those are decentralized file system where you can put all these, large chunk of data, big size data. And after you complete, if you have a lot of information, go for Hyperledger. It's very, very powerful private blockchain. And if you go for Hyperledger, you can go for Go language. It's very powerful language. So all these things you can learn. And if you want to know that how to develop a complete project having nice graphical user interface, if I click a button, the underlying smart contract code will be executed something. Then you go for GitHub, you go to that repository, and you can find a lot of applications, especially supply chain applications you can target first. Okay. Okay, that's all. Now at the end, what I do, I will just play one video. This is the last one. I hope you are not getting bored. So is it visible to all of you?
Yes, sir.
Okay. So I am now playing this video. And if the sound is not audible, so you can get the caption below. And this is about the supply chain. So I can give a brief idea that suppose I can tell you that in West Bengal, actually, a couple of years back, some meat was supplied to various hotels, and those meat was actually from dead animals. But it was very difficult to identify whether the meat supplied to all the hotels are pure, genuine, or from dead animals. There is no way of tracing, na. So, and after that, the all those culprits they got caught by the police, and then somehow. But in this case, whenever you are purchasing something from the market, it's very difficult to know whether this product is genuine or not, whether the product is being manufactured by this actual manufacturer written on the product or not, whether this is a duplicate or not, something. So you don't know how many distributors are there in between, how they have been transported. For example, when you are purchasing medicine, the medicine is coming from, for example, Mumbai. Do you know during the transportation correct temperature was maintained? You don't know. So this is completely not trustful, no? And transparency is not there. Now China has already developed so many things using blockchain, and this is the video I got, and it will give you a very nice idea that how blockchain will help. Let's see.
Sir, can we wind
Yes.
up because already it's time? So
Yeah, I understand.
Thank you for a really
Okay.
nice presentation.
Yes. Thank you. So it's just the overview that how you can apply blockchain in the supply chain context. Okay. Yeah. Thank you. So with this, I can complete my talk. Thank you.
I would now like to request Dr. Neeraj Mishra sir to propose the vote of thanks. It was really a very wonderful presentation and very informative, sir. And we'll expect you to come to our campus one someday and give a talk to the students physically. It was really very, very nice hearing from you, sir.
Thank
Dr.
you.
Neeraj Mishra sir, please propose
Yes,
the
ma'am.
vote
Yes,
of
ma'am.
thanks.
Yes, ma'am. Thank you, Papyadatta, ma'am. So good evening to all. On behalf of Bharat Institute of Engineering and Technology, Hyderabad, I am Dr. Neeraj Mishra, Associate Professor at BIT. So I take this opportunity to propose a vote of thanks to those who have directly or indirectly contributed to this 3-day international symposium. So the title of this symposium is Blockchain and its Application in Innovation and Entrepreneurship Development. So this is organized by our institute. So at the outset, I thank to our chief guest of the inauguration function, Dipan Sahu, Assistant Innovation Director at the Innovation Cell of the Ministry of Education and AICTE. And that is a lead role in the implementation of ARIA. So we are really enlightened with your knowledge and presence. So really your talk is very much informative and useful to understand this emerging technology that is blockchain. So today, that is the first day of the symposium. So there is a two keynote speaker on first day. The first speaker is Dr. Debasis Das from IIT Jodhpur, and the second speaker is Dr. Raju sir from IIT Patna. So really, sir, your talk are very good and informative. We learn so much knowledge here. So I just see here Dr. Debasis Das has discussed so many great concept like intelligent transportation system, and DSR protocol, and IoT device authentication concept, and some funding sources, means how we get some funding in this research domain. So really all are very means useful. This all means we all these concepts are very useful. And after that, Dr. Raju sir has discussed practical blockchain concept. Many things, many good concepts sir has discussed here, and sir has discussed the underlying concept of blockchain, what is a hash function, and what is a collision function, centralization and decentralization concept, many things. So I think this really all are very useful to enhance our knowledge. So thank you very much, sir, for you given your valuable time in this symposium. So we are thankful to our honorable sir, Chairman sir, C.H. Venugopal sir, for this motivation, and I would thank to our principal sir, Dr. J.P. Singh sir, and admin in charge, Dr. Sanjay Suman, for his enthusiastic support. So I special thank to our organizing committee, all the organizing committee, and some teaching staff, and their great support and coordination for making this first day symposium successful. So our heartful thank to our student faculty for active participation. So with this warm word and kind message, we move to the end of first day, the International Symposium. Once again, I thank to all the participant you given your valuable time, for your kind attention. So have a good day to all.
Okay, thank you all for your participation. So see you again tomorrow, 2 o'clock for the next session. Please do join the session 10 minutes before at 1:50. Thank you.